Good afternoon. My name is Olesia Barkovska. Today I represent Kharkiv National University of Radio Electronics. The presentation is devoted to research of some natural language processing method, and the title is Subsystem for Text-Based Emotional State Analysis in a Digital Scientific Community. The content of my presentation can be expressed in the following points. It starts from introduction, including motivation, analysis of related works and main goals. Then I present overview of motion analysis methods. Then we will focus on the quality assessment of the obtained results of the experiments. Lastly, the presentation ends with conclusion. Modern research papers confirm the relevance of the text analysis problem, which is based on generally accepted stages presented on the slide. The implementation of emotion analysis method in text processing is applied across various practical fields, some of which are illustrated in the figure. This technology enhances communication, increases team efficiency, prevents conflicts, and optimizes business and social processes. Existing sentiment analysis systems, such as Amazon Comprehend or Google Cloud Natural Language, often suffer from limitations in flexibility, adaptability to specific tasks, and transparency, making them unsuitable for domains requiring specialized emotional analysis. Numerous studies have focused on natural language processing methods in academic and scientific research, particularly in the areas of automated classification of scientific articles, citation analysis, and sentiment evaluation in peer reviews. Overview of emotion analysis methods using different approaches is presented on the slide. The aim of the work is to analyze the emotional reactions of participants of digital scientific communities based on textual information to determine their level of engagement and interest in the discussed topics, as well as to prevent potential conflicts and the pursuit of irrelevant research directions. This analysis demonstrates that transformer-based models, particularly BERT and DistilBERT, provide state-of-the-art performance across multiple natural language processing tasks. DistilBERT, in particular, offers a trade-off between accuracy and computational efficiency, making it a suitable choice for applications requiring faster inference. BERT, on the other hand, remains a robust baseline for NER and sentiment analysis, ensuring high accuracy and generalization capabilities. This slide presents text analysis blocks that we will research in next slides. The CoNLL dataset is a benchmark dataset for named entity recognition tasks. It is widely used in the field of natural language processing due to its well-annotated entities, including persons, locations, organizations, and miscellaneous entities. The experiments conducted are presented on the slide. Analysis of the obtained result shows that batch size 16 balances training time and model performance well. Smaller batch sizes significantly increased the training time without a noticeable increase in performance, which larger batch size reduced the training time but slightly worsened the performance. Training on 3 epochs gave the best overall performance. Also, 4 epochs showed minor improvement, and additional training time didn't justify the minor gains. 2 epochs were not enough for optimal training. The NER and post-tagging results show the system's ability to identify named entities and parts of speech in sentences. Text 1 identified the iPhone as a MISC, miscellaneous entity category. The system identified iPhone as a different entity because the product name doesn't fit into standard categories such as person, organization, or location. For the sentiment analysis model, we used the dataset you can see on the slide. This dataset is particularly valuable as it covers a diverse array of multilingual sentiment data, allowing the model to learn a wide range of linguistic and contextual nuances. The auto model for sequence classification model is a transform-based model specifically designed for classification tasks, including sentiment analysis. It simplifies the process of loading the Baird-based uncased model suitable for sequence classification, enable us to fine-tune it on our specific dataset. The experiments conducted are presented on the slide. The experimental results show that it is possible to ensure high model performance by adjusting several essential parameters such as batch size and number of training epochs. Batch size 16 and training on 3 epochs balance training time and model performance well. The table shows that epoch equal to 3 and batch size equal to 16 provides the highest indicators of accuracy, precision, recall, F1 score, and classification time. 4 epochs showed insignificant improvements. Additional training time didn't yield insignificant gains. The purpose of the block is to analyze the input data in the form of text and produce an output consisting of the sentiment and an accuracy score of the analysis. An example of this analysis is presented on the slide. The result indicates the system's ability to distinguish the overall emotional tone of complex sentences even when they contain a mix of positive and negative elements. The topic modeling component of our system uses BERT topic, a powerful and versatile framework for topic modeling that leverages transform-based embeddings and clustering algorithms to identify and extract topics from textual data. The dataset model showed on the slide is based on approximately 1 million Wikipedia pages from the popular dataset. Let me explain the result from these tables. Using the example of text 1 for BERT topic model, the main topic is Apple. The score is equal to 0.41 approximately. The probability is 0.59 approximately. The system identifies Apple as the dominant topic with a reasonable high score, and probability reflected the central focus on the iPhone. Other related topics include 6S, smartphones, and phones which are related to the discussion of Apple devices. The inclusion of the term discontinued 5S, phone, devices, and touchscreen further confirms the classification, indicating a complete understanding of the context of the Apple product ecosystem. The main topic Apple and related terms such as 6S, smartphones, and smartphone reflect the focus of the sentence on the iPhone and its features. The system's high probability score indicates a good understanding of the context. And finally, all previous studies were conducted specifically to generate and accurately present the markers in the format shown on the slide. Next slide, ensuring it matches the specific structure. A marker is the context of the proposed model is comprehensive contextual and syntactic information about a specific text segment. In the future, the marker can be used to solve many tasks beyond our system, as it serves as an universal indicator of sentiment, emotional tone, and the contextual component of the text. This study presents a comprehensive analysis of methods for evaluating the emotional state of participants in digital scientific communities based on textual information. The research primarily focused on topic modeling, sentiment analysis, and named entity recognition. The obtained result confirms that the combination of modern natural language processing techniques and machine learning enables effective analysis of scientific communication, improving researcher interaction, and enhancing the productivity of academic discussions. Thank you very much for your attention.